Yeah, Dina.
Okay, can everybody see my screen?
Yes.
I can see it.
Okay. Okay, so let me give a quick introduction about this project and also a demonstration of what we have working. So if you look at, I mean, just a little bit of a history here. We are a team that originally came from IBM, and we have had this project called Kruize, which has been which has been there for. Here's my other screen here. So it's been there on GitHub for a while. So this is the Kruize project, github.com/Kruize/Kruize. But so this particular project was what we first came up with, where we were monitoring containers inside Kubernetes. So we primarily come from a Java background, JVM developers working on IBM J9. And we saw that users of IBM J9 running it in Kubernetes clusters, running Java applications in Kubernetes clusters, were reporting errors of containers crashing. And when we debugged that a little bit more, we figured out that it was a problem of requests and limits not being set properly in Kubernetes. And then the question became, what should be the right values for requests and limits in Kubernetes? So requests and limits in Kubernetes, if you're not aware, so requests are guaranteed resources within Kubernetes that Kubernetes sets aside for a particular container. So, for example, X amount of CPU and memory, and limits are over and on top of the requests, which are usually shared among different set of containers running on the same node. So these two together help Kubernetes know whether an application is within legal boundaries of resource usage, and if it goes beyond limits, then it actually kills that particular container. And so we first wrote this Kruize project, which has since been deprecated, to just monitor your application for a long period of time, and then give you a recommendation in terms of what should be based on usage patterns, what should be the values to be set for requests and limits. But we then realized that that's not the only problem that administrators have. And the bigger problem that administrators have is really something like this, where the sizing aspect of containers is one part of the problem. So the bigger problem was something like this, where you have multiple applications or microservices running in a Kubernetes cluster, and the idea was that, or rather, the problem was that users were experiencing, let's say, some aspect of performance. I mean, for example, if this is a airline booking system, and you're trying to, let's say, a user is trying to do a flight booking. So maybe that's being handled by this particular microservice, and there's a web application out in the front, and all of these could be written in different languages and runtimes and so on. So the task for the IT administrator would then be to trace the API call along the way of all these APIs that are being used. Along the way of all the microservices that are being used, and try and tune that entire path. And as part of tuning of these microservices, one of the aspects was right-sizing them as well. So that was just part of this overall problem of trying to solve, higher-level performance issues. And so that's when this Autotune project came into being, which is essentially that I have a complex challenge where I have a complex definition of what should be the performance. And we call that the objective function, where it could be multifaceted, where maybe you want to reduce response time, but at the same time also keep the costs low as well, and also have the throughput higher, and maybe as an additional thing, maybe you want to keep the garbage collection time low as well, and so on. So there can be multiple such factors that go into the calculation in terms of the definition of what's the best performance for my application. So this is a pretty complex challenge, in the sense that it can only be accomplished by tuning the various aspects of the stack. So for example, if you're running a Java application, Java offers a lot of tunables. And these tunables, have, it's not very clear how they function within a container. For example, there's not been enough testing or even expertise around how Java behaves inside of containers, because it's only fairly recent happening, as opposed to Java running on bare metal, which has been happening since forever. So even experts are not very clear on how a particular application might function within a container, and how will it react to different load conditions and so on. So most of the times, IT admins would restrict their optimization techniques to, let's say, just increasing the resource usage, but not necessarily tuning the JVM itself, or even higher layers, for example, Spring Boot or Quarkus or any other part of the stack that they're using. And if you go below, the operating system parameters and so on. So all of these are way too, I would say, niche, in the sense that it requires a lot of knowledge in terms of that particular domain that you're trying to tune. And if you don't know, it's probably a good idea not to touch any of these knobs, because you don't know how or what kind of effect that it might have. So that means that SREs really have it really tough, because users are complaining, and well, developers give you lots of options, but then you are constrained in terms of the kind of options that you can choose, and it takes a really long time to perform these kind of experiments, and to do those manually, essentially. So that's where we thought that Autotune, this particular project came about, where we try to bring in all of these different aspects, objective, where you can specify all of your requirements as part of an objective function, and finally we provide a recommendation based on experiments that we run. So the architecture sort of looks like this right now, where the user provides a objective. It can be a complex objective where this can be an arithmetic or algebraic expression, and then you can also specify a direction, whether you want to maximize this entire objective function or minimize it. And also you can specify the hyperparameter-optimization algorithm that you want to use, and the function variables here represent essentially describe this objective function itself. So this objective function, for example, can be something like a squared divided by b plus c, and where a, b, and c are defined here in the function variable section. And each of these a, b, c are defined as a Prometheus query, for example. So this particular Prometheus query will represent, let's say, for example, a and b and so on. And that is what is essentially tracked by Autotune to determine the value of this objective function. And so this is what needs to be optimized. And so this is the exercise for Autotune to try and optimize this particular value. and either maximize it or minimize it. And this is applicable for a particular deployment that is chosen out here. So if this is applied to the cluster, then we have Autotune that's running in the cluster, which has a library of tunables. So these tunables are for specific layers. So for example, if it is a hotspot JVM, we have a bunch of tunables. If it is IBM J9, OpenJ9, then there's a different set of tunables, and Spring Boot and Quarkus and so on. So our Node.js or Python or Golang, whatever. So each of them can have their own set of tunables. And the analyzer component here would query this particular deployment through Prometheus. So it doesn't directly talk to these pods running in the cluster. It would talk to Prometheus, which is the metric provider, and get details about that particular application. So what are the layers? Is it a Java application? Is it a Node.js application, and so on? Once that layer information is available, it then applies the right set of tunables and then creates what is called the search space. So the search space, if you're aware of hyperparameter-optimization, consists of the objective function, the tunables, and the ranges within which they operate. So we then pass this off to something like Optuna, which is what we are using, which is the hyperparameter-optimization framework that we're using. And so here, Optuna, as you're aware, it supports multiple different algorithms. We have been using TPE primarily. It also has multivariate, which is more useful if you have dependencies between different tunables, and scikit and so on. Actually, Optuna itself is a sort of like a platform for different implementations of hyperparameter optimization, and there are other things like cat boost and so on that can also be used on top of Optuna. But we have stuck with the default, which is the Optuna TPE, and that's what we've been using for all of our experiments so far. And once we do that, send the search space off to this. So this one then gives us a config experiment, which is then deployed by the experiment manager to the cluster, and then we monitor the results, get the metrics, which is summarized and sent back to the analyzer here, which would calculate this objective function for. So for example, this particular trial can run for 15 minutes or 20 minutes. So each trial will run for about 15 minutes, and then the results are sent back to the analyzer, which would calculate this objective function and send it to Optuna, saying that for this particular config that you gave me, here is the result. And then Optuna will give another configuration, which will do this exactly the same thing. And so this loop will go on for, let's say, about 100 trials, where so this is where the Bayesian optimization is coming into the picture, where it tries to zero down onto the global maximum. If the maximum is what we are looking for, so it just tries to zero down to the maximum that the global maximum that we are looking for this particular objective function. And hopefully, we should be able to hit that within about 100 trials or so. We usually see that it takes about 60 to 70 trials for us to hit that global maximum. And so that's what we return back to the user as a config recommendation. So as of right now, this is our this has been our primary goal. Okay. So before I go in there, if there are any questions, I can stop, but I can just show you a quick demo otherwise.
Sorry, there's only a minuscule question to your bounds. Constraints of how often you run it. One comment there: why are you not considering also time-bounded optimization? So doesn't have to be iterative only. You can also offer to the customer saying, "Run it for 3 days, the optimization, and look, are you satisfied after that amount of time or not?" So only a thought. Maybe you have thought about it. You only were mentioning because it wasn't part of your presentation. I don't want to torpedo anything. I'm only mentioning it, and that was a part, so sort of a question.
Yeah, right. So I mean, I think it can be looked at in different ways. Actually, the other constraint which we seem to have, especially when we are talking about production environments. So I mean, it depends really on which area you are looking to optimize. In this kind of an environment where we are talking about where you have microservices and so on. In fact, it's the other kind of a constraint where they're saying, how quickly can you give us a recommendation? And currently, it takes us more than 24 hours because if you take 15 minutes or 20 minutes per trial, and if you have to run 100 trials, there's also the question of the experiment manager being able to deploy them, making sure that the pod has come up, and then monitoring, and then applying a user applying a load for it, and so on. So there's some amount of time that's spent in all of this stuff. And so it usually takes more than 24 hours, about 36 hours for this particular experiment to complete before we can come up with a recommendation. And so users are saying, can we do this faster? Because that's way too long. But if, let's say, we have to do this as a one-off exercise, which is where, like you said, maybe you want to run it for 3 days and really explore. Maybe you have a large search space where you have maybe 50 different parameters, and you want to explore all the different parts of the search space to arrive at a recommendation. It might take you 3 days. Absolutely. So we can specify we don't have this in this particular example, but we should be able to specify the number of trials that you want to run. So if you want to run 300 trials, that should be fine as well. And if it takes 3 days, that should be okay.
Thanks.
Okay, so this is a Minikube cluster that I have running on my laptop. I have a couple of applications. So this is a Tech Empower benchmark. Again, publicly available, github.com/techempower. So this is a Quarkus. So Tech Empower is a consortium of different benchmarks and middleware frameworks. And we are currently running the Quarkus RSTZ Hibernate benchmark. And this is the Spring Boot benchmark as well. And there's Autotune running in the cluster, as well as Prometheus, which is our data source. So I just got this running, and what I want to do is start a trial. So let me just show you. Start an experiment. So in this particular experiment, we are trying to minimize response time, and response time is defined as request sum divided by request count, where request sum is defined by this particular Prometheus query, and request count is defined by this particular Prometheus query. Autotune will keep track of these two queries from Prometheus and divide request sum by request count to get the value of objective function. So if I can now just apply this, it will initiate the experiment. You'll see that this experiment, you'll see that the PFP is getting restarted here. So essentially, actually, this is a dummy thing for the demo itself. Each individual trial, as I mentioned, will usually run for 15 minutes. But right now, for the sake of demo, I'm just running it for like a few seconds each. And so now, if I can show you the summary, so you can see that here, it's just basically finished a couple of trials, and the third trial is ongoing. And now the fourth one started, and so on. So right now these are all dummy values because it's it's just doing a dummy basically. But so this is how it cycles through all the different values. So I just wanted to show you the experiment details itself. So this is what is sent to the experiment manager here to run that experiment. So here we are saying, these are the options that are being set. So this is from the tunables. So you can see that it has set up some Quarkus tunable values. So this particular value has been set equal to 43. It's set this as server. We are using the G1 garbage collector max RAM percentage and max inline value equal to 44 and so on. So if you look at, this is the next trial number, and these have a different set of values, and so on. So this is for trial number for 2 and so on. So every trial it is sending out a different set of values, and so even these change. So these are the request and limit values, and you can see that CPU and memory values are being sent in, which are essentially different for each trial. So we try out these configurations which are provided by the Bayesian optimization, and then at the end of that, we look at the the best result out of all of these. Of course, right now it just runs 10 trials, and right now, because the values are all the same, it's just showing you that this is the best trial. But essentially, this is how we would go through this entire loop. But we do have some real world results, which, by the way, we are capturing in the Autotune results repo. So if you can, so if you can look into Kruize/Autotune results repo, this is where we post all of the results that we are running. These are actually run on OpenShift cluster. With this particular configuration, the same benchmark that you saw right now, the Tech Empower framework and the Quarkus REST-TZ benchmark. The incoming load is kept constant, and these are all the different tunables that we are using. So there are totally about 31 tunables across 3 different layers. The container layer has the CPU and memory. The JVM hotspot layer has a number of other tunables, and Quarkus has a few sub-tunables. And this is the range within which they operate. And some of these are just categorical, binary true or false kind of things as well. One thing that you need to remember is that whatever that you ask for is exactly what the Bayesian optimization is going to try and optimize for. So in this particular case, we are just looking to minimize response time. So that's exactly what it found. After about 100 trials, this was the lowest one that we found. So the default was 0.83 milliseconds. The one that Bayesian optimization found was 0.285 milliseconds. And similarly, so we ran this particular one in a different cluster. Here, this time, we changed the objective function to not only reduce the response time, but also keep the resources fixed. So we want to constrain that within 4 cores and 4 GB. And otherwise, in the previous experiment here, it was taking up a lot of resources, and you can see the results in this particular repo link that's mentioned here. So when we constrained it to 4 core and 4 GB, then the default value that we obtained was 5 milliseconds as the response time. But then with Autotune, we were able to get 1.82 milliseconds. But one of the issues with this one was that it had better performance, no doubt, as you can see, but it did have higher tail latencies. So the next thing that we looked at was to change the objective function to say, okay, we want to minimize response time, keep the resources fixed, but also lower tail latency. And we ran this on the same cluster, so this default value remains the same. But then you can see that this one is slightly higher than what we got here, which is 1.82. But with this particular value, we noticed that the tail latencies were taken care of as well. So And by the way, if you look at the cost, there is a cost reduction as well. I mean, even though we have kept the configuration as fixed, with 4 cores and 8 gig, it actually requires lesser instances of this configuration to handle, let's say, 1 million transactions per second, and that's where you get the cost reduction as well. And this was the final configuration that gave us this 1.91 millisecond for all these different tunables, with the ranges that you see here. And I mean, you can take a look at the results repo. We have, we keep posting results there as we run newer benchmarks and newer experiment combinations. Actually, so very quickly, we are working towards MVP. So these results that you saw here, actually, it's a combination of some scripts that we have and the hyperparameter-optimization library that we showed you earlier on. But we want to bring all of this into the the Autotune application itself, and so that part is expected to be available hopefully in a couple of months' time. And right now we are focused only on optimizing a particular single service, as in a single microservice, and this is not meant to be run on production environments as of right now. It's only for dev or QA one. I think one point that I did want to mention is that based on some of the requests that we've had, I think, I guess, Matt, you were probably looking for operating system use case, and we got a couple of other folks also looking to optimize for the operating system use case. And so we are looking to take this out as a separate service. I mean, right now, this is, by the way, running in its own container. So the way that we have productized it is that if you look into our, so we have 2 different Docker files here. One for the Autotune itself, which is written in Java, and Optuna one, which is basically a Python library. We want to basically, have this run as a separate service by itself. I mean, right now we do use APIs to reach out to Optuna, so it's already to some extent taken care of. But we would like to put it into a separate repo so that it need not cater to only to the Autotune use case as we are doing right now. It can be applied to any other use case, which might not necessarily need this whole Autotune framework, because primarily we are looking to use Autotune for Kubernetes, and we want to extend Autotune to also tune operating systems as well, running inside Kubernetes. But if there are completely non-Kubernetes use cases, we would like to separate out the HPO as a different service, so that there is a JSON API layer, I mean REST API layer that is there here, and you can just use that to send in any kind of search space, and it will give you a config experiment for you to try out as a JSON, and then you can feed back the results as a JSON as well. And so this can be completely taken out. So that's sort of the plan that we have, and I think I'll just stop there and hand it over to you, Matt.
Sure. First of all, I mean, to mention a little bit of esteem to us, to you, to your team. So the pleasure is greatly with me to have the opportunity exchanging with you people that have came to the same conclusions. What is lacking in the infra world? So I can only underline what you said. So I'm coming from the infra engineering world, open infra engineering world, and held there several roles. And I've always been frustrated with what is out there. So I mean, we all know TuneD, but certainly not of the character of what you have just described. And I also worked at several companies at various scales. And I can only tell that this is definitely absolutely needed, an automation to do around performance tuning. And I mean, performance tuning is simply often neglected because of very dull reasons, either resource constraints whatsoever, and that technology like this would actually tackle that. But I must also say I'm not a meta-heuristics expert or anything, so don't expect for me to talk too much about the intrinsics of let's say Autotune or whatsoever. So I'm really that what I said. I'm infrastructure engineer. So what I'm talking about here. So I must admit I have not prepared much material like Dino did, because to me it was also communicated that it's more about kind of assessing what could be the collaboration path, and so that's maybe more of a spoken material which I have here. But of course, I can also go share shortly also what I have online, so I can refer you to my documentation which I have accrued so far for the Godon project, which I'm here speaking for. It's mediocre. There are a few architecture illustrations and design illustrations. Some of that is also outdated. I'm still working on it, I must admit. Anyways, so for Godon, it's targeting really in nature this almost the same thing. So it's about optimizing infrastructure text throughout the stack, but it's not limited to Kubernetes. So, but you also said you're also intending to target it. But I mean, first citizen for you, this is what I understand, is Kubernetes, which is not necessarily the case for Godon. Right. So it's not only about operating systems per se, not only Linux or whatever. So it can be. So I would really like to see something that can tune anything. So it could also be a switch operating system whatsoever, as long as it's exposing its knobs to the world. Right. So what is it grown from? I have said this already. I was frustrated from what is out there in the open tech ecosystem for this purpose, and that's why I created the initiative myself to go about it. So that's so as you do, I'm also betting on meta heuristics, that is genetic evolutionary algorithms, but I'm agnostic to which framework to use. Autotune is fine with me. Could be another framework also in the future. Or I would like to see. I mean, I would like to, how to put it, be agnostic, because I promised myself from betting on any meta heuristics framework to get the best out of all the frameworks that are there. So get the best performance offering for the people that need it. Okay, so I'm also apparently, when I'm betting on meta heuristics, I'm also offering objective functions, which so the engine would be functioning similarly. Apparently, I'm behind Autotune, so I have less resources, to be blunt. It's few people working on it. There's only a research institution behind it currently, so it's also OSI, so it's an Oregon university where I have my infrastructure for testing and so on and so on. So, so for collaboration path, what can I say? So as it's very similar in nature, we almost have the same components. The only drift I see is that, I mean, I have a, let's say, more copyleftish license also for a reason. So HGPL v3. And I would also keep that. But so from my end, there's certainly no competition intended. So the initiative has the priority for me. So for me, it's important that the initiative succeeds in whatever format. Yeah, which probably is also conclusive from what I initially said, where it was growing from the whole project. So yeah, so as long as there's something coming that helps the infrastructure engineers to tackle the actual problems, I'm agnostic to which it is. So so I'm fairly prepared to phase out Godon in favor of Autotune. So okay, because for the point of what I said, because for me the initiative is important to succeed, and I'm not clinging to the project. Sorry, Godon. Yeah, as I said already, and yeah. So I mean, I could see that we parallelize our projects and we report to each other where we make insights. We can port use cases to each other's projects. We can contribute to each other's projects. Always use cases, of course. I mean, in the end, making code contributions. This is what I can think of. But maybe you have another mind here, or or I'm going into a different direction of what the original intention of the conversation was.
No, this is really good stuff to hear from you. Actually, that's great to hear from you. Actually, I did take a look at the Godon project. So I had some questions there. So when you mentioned about meta-heuristic algorithms, currently, which one are you using right now?
So first I was targeting Deep. That's a Python-based framework, which mainly uses, so it's mostly focused on genetic evolution algorithms. But with Autotune, I wasn't. I mean, it's also, I don't know how is it more recent than Deep, probably, but I'm also considering that now. So, and yeah, there are many more out there. So, is this answering your question?
Yeah, I'm just searching for this.
I can.
Deep. Okay,
So
do you have a
it's
link for this? Deep.
sorry. It's called Deep. Of course, I can find it for you. 1 second.
Oh, DEAP. Okay.
But I realized that I think it's certainly behind Autotune by now.
Okay. Not able to get a Google.
I liked it because it. Hopefully that works. I liked it because it has a in its mission statement to be distributed by nature. So so it could be how to put it, well applied to the to whatever orchestration engine one chooses. So it could be Kubernetes, whatsoever, because it embraces this this by its nature simply. Okay, so yeah, that's it.
Okay, I see egr.msu.edu. I see a paper that is referencing that. Okay. Okay, so yeah, okay, you sent the link. I didn't see that. Okay, yeah, I got that. Okay, I'll take a look at that. So I mean, you know, when we got that request, I mean, when we saw your request, I thought it would be nice to separate out the you know, the hyperparameter as a separate service. And you know, what we are, I mean, the current thinking that we have now is, you know, we should be able to, for example, if you are interested in Deep and that's what you would like to use, we can bring that into the hyperparameter optimization as a service that we are talking about. So it can be, you know, it can have a service which is basically having a API, I mean, a REST API that says, you know, for example, let me see if I have that link here right now. So I have an API that okay, 1 second, sorry. This is the one. Yep, I got that. Let me just share my screen. So it'll be something like this, where you know, we have I mean, it should actually be HPO REST API. So we'll have a HPO REST API which will have something like this. So that, you know, that this is you're starting a new experiment, and we provide, there's a URL which can pull the search space, and so essentially the list of tunables and the objective function and things like that. So that is available at a URL which we send to Autotune, and we say that start a new experiment. And so it will pull in that search space and start the experiment, and then it gives you a trial number, and then, you know, you can use that trial number to get the actual configuration values for that particular trial. So this is like, I mean, something like a generic API that we are using currently. And we can have the same API for, where we can specify the algorithm, the library itself, where we can say, okay, I want to use Optuna, or I want to use Deep, or some other stuff. And so here we can specify the library as well. And based on that, it would, query that particular library and start that experiment with that, and give you the results in the same way. So you have a generic API which can handle any of the libraries and the way that it works. And so there are other. As you mentioned, there might be other. I know that Twitter is working on. I think they have their own HPO algorithms or libraries that they have been working on for a while. And I know that IBM has done some, currently which are proprietary ones, but they're talking about open sourcing that as well. So I'm sure that there are multiple such kind of libraries that are that are available, and we can bring all of them into the same fold here and have a generic API that allows you to access any one of them depending on what are your needs, and essentially, then. Depending on your particular use case, you can use any of them, and we have a common framework that allows you to deploy this particular this particular service, whether if you want to be deployed in a container or on bare metal or inside of a Kubernetes cluster. We should be able to do all of those kind of things, and making sure that it is tested and production ready and those kind of things. And so if we have that kind of a framework, would that work for you?
Yeah, it sounds good per se. There's many questions arising from that. I'm not sure. Do we have the time? For example, one point, but it's already a technical detail. I would say, for example, would it then also? The API hides this from you. Would it also then internally allow for things like that you let algorithmic frameworks compete with each other, because you could gain something from that, or many more questions. So maybe I gather that and forward that in some other channel. But essentially, it sounds good. What other thoughts do I have?
Yeah. So we can, actually what we have is we are working on a document to detail, what I just mentioned, and we are, hopefully it should be available in a couple of days' time. So we'll circulate that once that becomes available, so that you have a better understanding of what I just mentioned, which talks about what this HPO as a service is all about, and how is it, how are we planning to architect it, and so on. And of course, hopefully have its own repo as well, so where you can try things out and so on. Maybe we can have a follow-up call where we would have already circulated this, and you can take a look at that. And if you have any questions, of course, we can always discuss on Slack, and then come back to have another call where we can thrash out some of these details.
Yeah, sounds good to me at first. Yep, I have to process all of that also somewhat. So
yeah, sure. Okay, and so currently is you mentioned that you're primarily working in an infra environment. So what are the use cases that that you are most interested in? Is it primarily operating system tuning, or are there other ones that you're also worried about right now?
I mentioned initially, so I see potential for much. So as I said, so network operating system is a good example. I'm not a network operating system expert apparently, but there's of course, it's also bounded by how much computation resources so one can put into the optimization processing and so on. But yeah, so that there I see much potential. Where else? So operating system, so hardware. I mean, there is even hardware that offers knobs and so on and so on. So so certainly also on the let's say lower layers of the infrastructure. Everything that can be reached via the network potentially. So which has an API, for example. So I mean, it could be a BMC, you know.
Okay. Yeah.
I mean, of course, it's also down to that somebody implements it. I'm not saying that, you know, but it should be possible for someone who says, I have a dire use case here. I would like to have a framework where I can implement this. And if you prepare the stage for that, that could be very good.
Right. Actually, the thing is, in fact, we, you know, the TuneD and the node tuning operator teams are also there in Red Hat, and we did talk to them about this, and we are looking to see if you know, we can bring in the TuneD into the same Autotune framework as well, where so you know, so I think I did not really show that part, but the way that we are storing tunables is actually just a YAML file in the Autotune project. And so each of these layers happen to be just a YAML file. So you have a hotspot YAML file, container YAML, and Quarkus, and so on. And so we plan to do the same thing with operating systems as well, where we have a number of tunables that are available, and the ranges and things like that. And then of course have specific objective functions for which focus on operating system you know, optimization. And then to be able to deploy that. So right now, of course, the experiment manager, as you saw, is you know, working with Kubernetes to do the microservice deployment. And similarly, it should be able to talk to the node tuning operator and send it a YAML that the node tuning operator understands for it to deploy the operating system tunables and updates that we would like as well. So that part we hope to do that as part of Autotune itself. But in general, you know, for all the different use cases that you mentioned, I completely agree that, you know, there has to be essentially a deployment framework. So what we need here is, you know, the tunables, which can be, you know, so we need to standardize the format in which you can specify the tunables, which is what that API that I just showed you is about.
Essentially, yes.
Yeah. And so once you standardize that, so you say, okay, here are the bunch of tunables that I have and the ranges within which they operate. You can give it to the HPO as a service, which will give you a config. And now you take the config and you need a way to deploy that. You need a deployment engine, which is, you know, like I said, BMC. You need a different deployment engine for BMC and for some networking stack or operating system or microservices and so on. And then you know, monitor how that particular configuration performs under load, and then get the results back, and then feed it back into the HPO as a service.
Correct.
So these are basically the workflow, and so that's the document that I was talking about. So we want to you know, put all of this in that HPO as a service documentation and say that, you know, this is what we want to build. I mean, it's not there as yet, but so for example, if you want to plug in a module that can work with BMCs, you should be able to just plug it in and it should work, and so on.
Correct.
So that's the idea essentially.
Yeah, I mean, yeah, exactly. So the customer shouldn't have to think about how her tunables or whatever his optimization flow is effectuating the change and interpreting and so on. Yeah, so it should simply simplify the optimization for the customer. Exactly. So, but for the TuneD topic, so I was already alluding to this, and as I said, I don't want to. I mean, of course, you have in Red Hat, and so you have to. There's also probably politics ongoing and so on. Anyways, so the thing is, TuneD. I mean, for me, if you go through it, it would only be a proxy in my mind and it would take out the might of the HPO. So that I would rather expect that you directly apply the configuration that was distilled or whatever you want to call it, or refined, and then interpret from there without going through this proxy, because TuneD has its own tuning engine in the end. It's trying out tunables, but in a far less sophisticated way than an HPO can do. I would claim it cannot explore the parameter space in a way the HPO can do, and also probably not in the time scale and so on. So maybe I'm less.
Sorry.
I'm not enough TuneD expert in this way, but I'm only saying this is my point against doing such steps.
Okay. Yeah, actually, one point I forgot to mention. I mean, what we are trying to do with TuneD is. So as you mentioned, they had arrived at I would say optimized values based on some kind of experimentation that they have done in the past. So for example, they have fixed that. So let's say you have maybe database profile, a database performance profile. So they have previously done some experiments where they say, okay, large pages equal to so and so, and networking, some sysctl stuff, and so on. So they have set up all. I mean, they've done these experiments, and based on that, they actually have standardized a performance profile, like a database profile or a throughput profile, and so on. But what we are doing with that team is to use HPO to actually arrive at better values for TuneD itself. So TuneD has some certain parameters, and so they have certain profiles and they have parameters.
Yeah.
And so what we are doing is helping them to use HPO as a service to take all the parameters from them, arrive at better values for the standard profiles that they have, so that it is better applicable in the current context. So that's one part. And the second part is that I agree with you that we don't need to go through TuneD. So there is actually I think no tuning operator allows you to create a custom tuning set, which is essentially something that has come from the Bayesian optimization, which says, okay, try this config. And so the no tuning operator just takes that config and deploys that, and then we monitor the workload to see how it performs. And and then at the end of all of these 100 trials, we find a particular configuration which is best suited for that, then we can apply that. So it just so happens that the application is being done by the TuneD, because so here the thing here is we as Autotune are running with very less privileges inside the Kubernetes cluster and things like that. So whereas TuneD has all the it has the necessary operating system privileges to make changes to the underlying operating system itself. So that's where we were bringing in TuneD to be able to deploy the config, the custom config that is coming in from HPO. That's the way that we're looking at it.
Okay, if it's a security-wise enabler or something, okay, it's a different story. But for example, for the profiles, I can say, for example, I looked into a few profiles. There was also I cannot say something to all the profiles, but there are certainly parameters lacking, for example, for the networking stack in Linux. I saw that they're certainly not even touching all possible tunables, and so it should also be in the hands of the customer. Which tune, if you say I'm tuning this profile, then you dictating to the customer of your API what tunables they can choose. But it should be broad. I mean, it should be all the tunables that the operating system, let's say here in this case, offers, or also the hardware that the operating system abstracts. So so that would be would be confining again the might of your solution in the end. And that's a concern I want to raise. I'm not saying you cannot do that, or you shouldn't do it. It's only, you know, a concern I raise, and maybe there's even a solution for that, reconciling the both worlds, and that's all what I'm saying here. Okay, so I erased it, and that's it.
Yeah, no, I mean, that's absolutely valid point that you raised. I think part of the problem that that team had is that, you know, they were trying to do these experiments manually. And so, you know, there's only so many tunables that you can handle.
Of course.
You know, when you're doing it manually. And so, like exactly like you said, now that if you use HPO as a service, it really can handle, you know, a lot many more tunables than what they were trying to do manually. And I completely agree with you that we need to have a standardized set of operating system tunables. You know, just like we have it for, let's say, you know, the JVM that I was showing you earlier, where we had about, you know, 13 or so JVM tunables. So just like that, we can have a broad list of all the operating system tunables for Linux or any other operating system, and, you know, have different YAML files for each of them, and the users can possibly choose from that. So maybe for their particular use case, they can say, you know, I only want you know, XYZ set of tunables, and not all of them. So yeah, I think I completely agree with you on that.
I mean, the customer should be constrained by the choice of tuners. They should be constrained by what they can afford in optimization processing in the end, at most.
Yeah.
So, okay, but I think that we are on the same page here, and there's not anything to add. Yeah. Good.
Okay. I think we are out of time as well.
Yeah.
So, yeah, thank you so much, everyone, for joining us this time. I hope it was useful, and definitely we'll keep having these calls, and, you know, we'll continue to talk on Slack as well. So thank you. Thanks all.
Thanks for the invitation. Thanks to everyone. Thanks for the opportunity to meet you. Cheers. Bye.
Thanks, man. Take care. Thank you, everyone.
Thanks, Dino. Thanks. Bye.